Hello friends, I am Banthiya and you are looking at Banthiya's Training and Consultancy. We are looking at mole concept and stoichiometry chapter, in which we are dealing with a couple of questions based on mole concept and Avogadro's law. And today we are specially going to deal with vapor density concept. So let's start. 500 ml of gas X at s.t.p weighs 0.50 grams. Calculate the vapor density and molecular weight of the gas when 1 liter of H2 at s.t.p weighs 0.09 grams. Now vapor density formula is mass of a certain volume of gas divided by mass of same volume of H2 gas. And here we are given that 500 ml of a gas X at s.t.p weighs 0.5 grams. If we have to consider 1 liter of gas X, then the weight will automatically become 1 gram. So 1 gram divided by 1 liter is 0.09 of H2. When we solve this, we get vapor density equals to 11.1 and molecular weight equals to twice into vapor density. So molecular weight comes out to 2 into 11.1, that is we get 22.2 as the molecular weight of the given substance, given gas X. Now let's look at the next question. A gas cylinder holds 85 grams of a gas X. The same cylinder when filled with hydrogen holds 8.5 grams of hydrogen under the same condition of temperature and pressure. Calculate the molecular weight of X. That's pretty simple question, guys. Vapor density equals to weight of the given gas in some volume divided by weight of the same volume of hydrogen gas. So here we get vapor density equals to 10 and molecular weight equals to twice of vapor density. So 2 into 10, that is 20, will be the molecular weight of the given gas X. Now let's look at the next question. Calculate the relative molecular mass, that is molecular weight of 290 ml of a gas A at 17 degrees Celsius and 1520 mm pressure, which weighs 2.73 grams at s.t.p. 1 liter of hydrogen at s.t.p weighs 0.09 grams. Now it's a bit complicated question because here we have added both the concept, that is concept of mole and the concept of vapor density is coming together in this question. Let's look at it. So P1 V1 by T1 equals to P2 V2 by T2, and let's assume P1 V1 by T1 are the pressure, volume and temperature at s.t.p. So we get pressure at s.t.p is 760 mm of Hg. We don't know the volume and we know the temperature at s.t.p is 273 Kelvin, which will be equals to pressure is given 1520 into volume is given 290 divided by 17 degrees Celsius, that will be 290. And when you simplify this, we get volume at s.t.p as 546 ml. Now 546 ml weighs 2.73 grams at s.t.p. 546 ml weighs 2.73 grams. We want to find what will be the weight of 1 liter of the same gas. So we get X equals to 2.73 into 1000 divided by 546. When you solve it, we get X equals to 5 grams, and from this we can easily calculate vapor density. So vapor density equals to given mass in 1 liter and mass of 1 liter hydrogen, that is 0.09, which comes out to 55.55, and we know that molecular weight equals to twice into vapor density, and hence we get 2 into 55.55, that comes out to 111.11, and that is your final answer. Now let's look at the next question. Guys, I want you to solve this question by yourself before I do it. So please pause this video right now and let me know if you were able to solve this question by answering in the card above. So let's look how it is to be solved. State the volume occupied by 40 grams of hydrocarbon, that is CH4 at s.t.p, if its vapor density is 8, and hence the molecular weight will be twice into vapor density, that is 2 into 8, that is 16. So we have got the molecular weight. And state the volume occupied by 40 grams of a hydrocarbon, that is CH4 at s.t.p. Now 16 grams, which is the molar mass, will occupy 22.4 liters, and we have been asked 40 grams will occupy how much? So X will be 40 into 22.4 divided by 16, which when you simplify you get 56 liters, and this is your final answer to this question. Now let's look at the next question. Calculate the atomicity of gas X, which has atomic mass 35.5, whose vapor density is equal to its relative atomic mass. Atomicity is basically if X is one atom of a particular element, then to form a stable molecule, whether it needs 2 atoms of X or 3 or 4, that is called the atomicity. That is how many atoms are in one molecule of that particular atom or molecule. So calculate the atomicity of gas X, whose vapor density is equal to relative atomic mass, and the atomic mass is given 35.5. So the atomic mass is 35.5 and vapor density therefore is 35.5, and we know that molecular weight is twice the vapor density, and hence we can simply state that 2 atoms of atom X is required, that is its atomicity. So that is atomicity of X gas. I hope guys that you have understood. In case you have any doubt, please comment in the comment section below. Now let's see the last question of today's session. Calculate the relative molecular mass and vapor density of methyl alcohol CH3OH if 160 gram of alcohol on vaporization has a volume of 112 liters at s.t.p. 160 gram will occupy 112 liters. So 22.4 liters will occupy X. So X will become 22.4 into 160 divided by 112, which becomes 32 grams, and this is the molecular weight. This is the molecular weight of that particular gas. Now once we have got the relative molecular mass equals to 32 grams, we can find the vapor density. So vapor density equals to molecular weight divided by 2, and hence 32 by 2 will give you 16. So vapor density will be 16 and the molecular mass will be 32 grams. And that's the final answer. I hope guys that you have enjoyed and understood the concepts and you had fun solving the questions with me. Thank you for watching this video, and in case you have any doubt, please feel free to comment in the comment section below and get your doubts cleared. Please like, share and subscribe my channel, and don't forget to hit the bell icon if you don't want to miss any update from my channel. Thank you.